This is section 3.3, number 59. And so they give me a function and they just want me to find the derivative. So here I go. F of x is x times the square root of x squared plus 3x. Okay? So what rules are going to be coming into play here when I go ahead and take the derivative?
Chain rule and something else.
Chain rule and something else. Well, what do you think?
Product rule?
I think so. I mean, what's being multiplied?
X and square root.
You've got x and you've got this big square root, right? So I'm picturing that that's going to be my u, and that's going to be my v, right? One thing I would do is I would rewrite f of x. I would write it this way. X times, and I'm going to put this x squared plus 3x in parentheses and then do what to it?
Raise it to the half.
To the 1/2 power, that's right. It's funny, my daughter, just this morning, she's doing algebra right now, like algebra 2, and this is exactly what they're doing. It's just that whole idea of what do fraction exponents mean? She was just asking me questions this morning about it. But yeah, I'm picturing that my x here, this is my u, and this mess here, that's my v. Okay. So when I go ahead to compute the derivative, right, I'm going to be using the product rule. So f prime of x equals, well, I know the rule. When I take the derivative of uv, it's going to be u prime v plus uv prime, right? That's what's going to happen. So I have to go ahead and kind of follow that model. And so what's u prime? Well, u is x, so what's u prime? Well, derivative of x is just 1, right? So I get 1 times, and then we said v is this x squared plus 3x to the 1/2 power plus, well, u is x, and now I have to do v prime. So this is my bing bing bong from Friday, right? So let's see. Bing! There's the 1/2. And I remember the second bing some of us were missing. So what happens in the second bing? What do? We're going to write this x squared plus 3x down again, right? But what are we going to do? Raise it to, go ahead.
Negative 1/2.
The negative 1/2, because you just take that exponent and lower it 1, right? And then bong, there's one more thing I have to remember to do, and what's that? The derivative of the inside, right? What would be the derivative of the inside? It would be 2x plus 3. That's the chain rule going on. Now, Ben, you asked the question. You with me so far?
Yeah.
Okay. So now, maybe does the back of the book have something simplified that's different than what I have? Let me work on it and just kind of show you what I would do next. I would do this. I would write this part as the square root of x squared plus 3x, right? Now, please understand, though, on Friday's test, in terms of taking derivatives, you're done. Okay? You showed me the derivative. Okay? But let's see if we can get what the back of the book has. So plus, well, to me, I'm going to write a fraction, right? Because I have a negative exponent. You guys see that? So the square root is going to go in the denominator in this fraction, x squared plus 3x. Now there's an x in the numerator. There's a 2 in the denominator. I'll put it right there. That comes from the 1/2. And this 2x plus 3 is also in the numerator. Brian, question?
I'm just trying to absorb.
Yeah, I'll stop for a second. Okay. A lot of times the back of the book will try to write it as one big fraction. And there's reasons for doing it that we're going to get into soon. Okay? It's actually 2 chapters from now is when we really hit it. All right? Now this, so next week at this time we'll be starting to get into it, I would say. How do you write this as a fraction? Well, that's easy. I can write it as that over 1. There's nothing wrong with doing that. The square root of x squared plus 3x over 1. And the reason I write it as a fraction is because what I'd really like to do is I'd like to add these 2 fractions. Like I said, make it one big fraction. So it's funny. The calculus in this problem took me 1 line. Now it's a bunch of algebra. Really? Well, what do you need to have if you want to add fractions? You need to have what? A common denominator, sure. And the common denominator that I'm going to try and get is 2 square root of x squared plus 3x. Because I already have it over here. And basically, if I want to get 2 square root of x squared plus 3x, okay, well, this numerator here stays the same. It does. The other numerator is going to change. That's going to change. Because how do you get a new denominator? Well, you take the fraction, you multiply top and bottom by the same thing, right? So I guess the question is, do you know what I'm going to multiply top and bottom by? Well, by that, right? See, I'm going to take this fraction, and I'm going to multiply top and bottom by 2 square root of x squared plus 3x. I'm not changing it. I'm multiplying by 1, right? Same thing over itself. But I am changing what it looks like. Okay, so what's the numerator become? Well, I think it would become 2 times parentheses x squared plus 3x, because square root times square root, the square root goes away. Is that right? Now I can add the fractions. All right, I add the fractions. Denominator stays the same. 2 square root of x squared plus 3x. Okay? Now how do you add those numerators? Well, I guess, let me distribute. I get 2x squared plus 3x from this piece, and I get plus 2x squared, plus 3x from this piece, right? So I just distributed the 2, and I distributed the x. That's funny, it's the same thing though. Oh, this is not 3x, what would this be?
Yeah, why are you not getting 6?
Yeah, you're going to get 6x. That's going to get 6x. Okay, that's better. So now I'm getting, as a simplified answer, 4x squared plus 9x, right? 6x plus 3x is 9x, over 2 square root of x squared plus 3x. Is that what they have? See what Bob has.
Close.
Close?
Yeah.
Okay. Does he have no radical in the denominator? What's his denominator?
2 times square root of x times x plus 3. X plus 3 being in parentheses.
Oh, okay. So we missed something here. Is the x and x plus 3 both under the square root?
Yeah.
That's all he did is he factored this. See that? He wrote, instead of that denominator, he wrote 2 square root of x times x plus 3. Is that what you're saying?
Yeah.
Is the numerator the same, or did he factor anything?
Yeah.
Took out an x and then has 4x plus 9, right?
Yeah.
Okay. Now why? Why would we want to write the derivative that way? Okay? Well, remember what the derivative gives you. The derivative gives you what? Why do we compute derivatives? To find the slope. Slope of a tangent line, right? Now, here's the point. You have some function. I don't know what the graph of this function looks like, but if you have some function. Suppose I want to know where's the maximum value of that function. Well, I can see it, right? It's right there. Hey, what's the slope of the tangent line going to be when you're at the maximum there? Yeah, that slope is 0, right? So what's coming is this. You look at the function that's the derivative and you say, how do I make it equal to 0? Now, if you write it in this format here and say, how do I make it equal 0? Ooh, that's a hard problem. That's a hard algebra equation. But if you write it as a big fraction and set it equal to 0, and say, how do I make a big fraction equal to 0? That's a lot easier. The way to make a big fraction equal to 0 is you make the numerator 0. Are you with me? So really, you do all this work. All it really comes down to is, can you solve the equation 4x squared plus 9x equals 0? If you can make the numerator 0, then you'll know kind of where they're called critical values. You'll know where the critical values are. Where are the places that we might have a maximum? Well, how would I solve that green equation? 4x squared plus 9x equals 0. Do you guys know? Well, you'd factor. That's why a lot of times we factor. So in the back of the book, they factored the answer in the numerator. They also factored the denominator because that'll kind of tell you where you might have vertical asymptotes. Remember, we talked about that. Non-zero over 0. Are you with me? So these are the kinds of things that you look for. Critical values are where you get a 0 in the numerator or the denominator. So the author's already kind of warming you up for what we're going to do with these derivatives as we progress through the course. So that's a good question. I can see why you didn't get the back of the book answer. So on your first test, if you guys can get this far, I'm cool. But by the second test, we're going to have to do some stuff with it. So that's kind of where we're heading. Other homework questions?